Bismillahirrahmanirrahim. So in this video I will explain about the difference between the Taylor's and Maclaurin's polynomial with the remainder. So for the question, we want to find the Taylor's and Maclaurin's polynomial for functions of x is equals to the ln 1 plus x of degree 3 near to x equals to 1. So for the Taylor's, first step we derive the function to the degree of 3. So 3 times we derive the functions, so we get this function of x is ln 1 plus x. Function prime x is equal to 1 over 1 plus x. Function double prime x is equal to negative 1 over 1 plus x squared. Function of triple prime of x is equal to 2 over 1 plus x cubed. And for this we substitute the value of x into the function, so we get for f1 equals to ln 2, f prime 1 equals to 1 over 2, f double prime 1 is equal to negative 1 over 4, function triple prime of 1 is equal to 1 over 4. So we this is the pattern to write the polynomial of the Taylor's. So we use the degree of 3, polynomial degree of 3 power of x is equal to function of 1 plus function prime 1 divided by 1 factorial times x minus 1 plus f double prime of 1 divided by 2 factorial times x minus 1 squared plus function triple prime of 1 divided by 3 factorial times x minus 1 cube. So then for this polynomial, we just substitute the function that we have, insert the value of x. So this is the polynomial list. And for the remainder, we use the general formula of the remainder of Taylor polynomial, where Rn of x is the remainder or error is equal to f power of n plus 1 of z divided by n plus 1 factorial times x minus a power of n plus 1. So we already have the values, we substitute into the formula. Degree of 3, so equals to a function 3 plus 1 is equal to 4 of z divided by 4 factorial x minus 1 power of 4. So this is derivative of function at 4th degree. Negative is equal to negative 6 over 1 plus x power of 4. So we assume that z is the number between the value of x and a. So I use 1 over 2. So we insert into the function that we have derived, function of 4th degree. So we got negative 32 over 27. So we substitute into the remainder formula. Then we got this negative 4 over 81 times x minus 1 power of 4. So we compare to the Maclaurin polynomial. So we derive same like Taylor's polynomial, but the function we know that Maclaurin is centered at 0. So we substitute 0 into the function that we have derived. So function of 0 is equal to 0, function prime of 0 equals to 1, function double prime 0 equals to -1, function triple prime of 0 equals to 2. Then we do the polynomial list. So is equal to 0 plus x minus 1 over 2x squared plus 1 over 3x cubed. So that is the polynomial of the maclaurin. And the remainder also is different formula. A difference here because Taylor's x minus a, but in the maclaurin we use the x only because we centered at 0. So the same one, we find the derivative of 4 degree. So we got negative 32 over 27. Then we substitute into this one, we got the negative 4 over 81 times x power of 4. So if you want to compare the remainder of maclaurin and Taylor's is more, Taylor's have less error, which more accurate compared to maclaurin. So that's the difference between the maclaurin and Taylor's polynomial with remainder.